Hi, today we're going to take a brief look at multiplying monomials. We're going to start with a quick review on what is an exponent and multiplying powers with the same base. First of all, what is an exponent? An exponent is a mathematical way to rewrite an expression where the same number, or variable, is being multiplied by itself repeatedly. My first example, we got 2 times 2 times 2. Note the 2 is being multiplied by itself 3 times. So mathematically, we can rewrite that as 2 raised to the third. The 3 is the exponent. It's being raised as a superscript, a little number being written up into the top. If we look at the little parts of this, the 2, the number that's being multiplied by itself multiple times, is better known as the base. The number of times the number is being multiplied by itself, in this case the 3, is known as the exponent. Overall, the whole thing, the 2 raised to the third, is known as a power. I am going to warn you, some people use power and exponent interchangeably. For the purposes of this video, I will stick to exponent. Power will be both the base and the exponent put together. We can do this with variables as well. For my next example, we have x times 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 x. Oh, that was long. Basically, if we count them up, we got 9 x's being written out, so we can rewrite it as x raised to the 9th. 9 would be the exponent. X raised to the 9th is a lot shorter than writing x times itself multiple times. For the next one, you can also have multiple variables in the same problem. For this one, I got x times x times x times x times y times y. If we count up those x's, we have 4 of them, so x is raised to the 4th. For the y's, notice there's 2 y's there, so y is being raised to the 2nd, or some people say y is being squared. Next, we're going to look at what happens when we multiply powers with the same base. For this example, we're going to start off with 5 squared times 5 to the 4th. If we expand that out, 5 squared is 5 times 5. The 5 to the 4th is 5 times 5 times 5 times 5. Notice everything here is being multiplied together. So all of the 5's are getting multiplied together. If we count them all up, there is a total of 6 of them. So we can write out the answer as 5 with 6 for an exponent. For my next example, we have x to the 3rd times x to the 7th. The x to the 3rd can be expanded, and the x to the 7th can be expanded. Since everything's being multiplied together, we can combine them all, and if we count up all of those x's being multiplied together, we would see we have 10 of them. So we can write the answer as x with an exponent of 10. Now, some people wisely know there's a shortcut to this. If we go back to our first example with the 5 squared times 5 to the 4th, if we look at the exponents, the 2 and the 4, if we take the 2 and the 4 and we add them together, we're going to get 6. Notice the answer was 5 raised to the 6th. If we check the one out with the variables, we have x to the 3rd times x to the 7th. So if we take the 2 variables there and add them, we would get 10. The answer is x to the 10th. So you can shortcut the process. As long as the base is the same, you may add the exponents. So that brings us to what we want to do. We want to be able to multiply monomials. My first recommendation is to look at the variables. If there's not an exponent written with each variable, fill in a 1. So for that 5xy in front, let's put a 1 with both the x and the y. And in that 3x squared y, let's put a 1 with the y. Now we need to multiply. So first we're going to multiply the coefficients, the 5 times the 3, and we would get 15. Now we're going to start with the bases. Let's start with the x. If we look at the exponent on the x's, the first term has an exponent of 1, the second term has an exponent of 2. 1 plus 2 would be 3, so we have 3 x's being multiplied together all together. If we look at our next base, the y, the first term has an exponent of 1, the second term has an exponent of 1. 1 plus 1 would be 2. So our answer in this case would be 15x to the third y squared. If we look at our next example, once again, you want to start by filling in 1 for any variable that does not have an exponent. So in the second term, let's put a 1 with the x. We multiply the coefficients. In this case, negative 4 times 7 would give us a negative 28. Now we start with our bases. For the x, we have an exponent of 4 with the first term, an exponent of 1 with the second term. 4 plus 1 would be 5. If we look at the y's, we have an exponent of 2 with the first one, 5 with the second term. 2 plus 5 would be 7. So our answer would be negative 28, x to the fifth, y to the seventh. Next example. Once again, let's fill in ones where any variable that does not have an exponent. We'll multiply our coefficients. 2 times negative 3 would give us a negative 6. And now we start with our bases. If we start with the x, first term has a 1 and a 3 for the exponents. 1 plus 3 is going to be 4. Alphabetically, y comes next. Note if we look at this one, the first term does not have a y in it. That's okay. If we look at the second term, however, it's got a pair of y's in there, 2 of them. So we're going to have a y squared as part of our answer. As far as the z's go, and I'll warn you, I put a line through my z's just because I write my z's a little on the sloppy side. Don't want it confused for a 2. If we look at the exponents, we got 4 in the first term, 1 in the second term. 4 plus 1 would give us 5. So our answer is negative 6, x to the fourth, y to the second, z to the fifth. And for our last example, once again, any place where the variable does not have an exponent, we would like to put in a 1. We multiply our coefficients together. Negative 8 times negative 11 will give us a positive 88. And then we start with our bases. For our x, got an exponent of 5 and an exponent of 2. So 5 plus 2 would give us 7. Next base is the y. We got 1 in the first term, 1 in the second term. 1 plus 1 would be 2. So we have 2 y's multiplied together. And then as far as our final base, the z, we have an exponent of 6 in the first term, an exponent of 3 in the second term. 6 plus 3 would be 9. So our final answer would be 88, x to the seventh, y squared, z to the ninth. So there you have it. Brief description of multiplying monomials. I hope this has been helpful for you. Have a good day.